Hey peeps, it's Sophie from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're dealing with the 2018 Physical Sciences Grade 10 paper, and this is question 9 on magnetism. So, it shows four metallic bars suspended freely from the ceiling. They interact as shown. The X and Y bar magnets are separated by a distance of 4 centimeters, and they are 5 centimeters apart when suspended, and there are two other bars, A and B, and it says that one is iron and one of them is iron and the other is made of gold. So the first question, which is 9.1, says write down the term describing a material that is easily magnetized, and we know that this is a ferromagnetic material. And we know the most common ones spell out this cool little acronym, or FCONI, and that stands for iron, cobalt, and nickel. But that's just as a side note there. Okay, then it says which one of the bars, A or B, is made of iron. So if we have a look at some of the bars, A is just staying stagnant like that, it's not moving at all, but B is at this, it's being attracted to something, which kind of suggests that it is a ferromagnetic material. So then we can say that actually it is B that is iron, because it's being attracted to that Y bar there. Cool. 9.3 says determine the polarity of bar B closest to the bar magnet Y and write only north or south. So we can see here, so if they've given us that there is a north on one side of X, we can work backwards. There would be south on this side, and because these two are repelling each other, which you can see because they're far apart, you know that this side of this bar magnet is going to be south, which means that this side is going to be north, and these two are attracted to each other, which means that this side is going to be south. So 9.3, south. Great. So we need to explain the answer 9.4, which we've just done. We say that X and Y repel each other as shown in the diagram. So they have like polarities on either side. So there's a south and a south. And you can draw the diagram out as we've drawn it out there. Great. So then 9.5 says sketch the magnetic field pattern around bar magnet X. So let's go and do that. 9.5. So remember, your lines should not be touching and they should be the same. So let's write as X has come out. So that's north, that's south, and we know that field lines out of a bar magnet always go from north to south outside of one. So let's just draw them. So we know that this is going north to south, and this here, we'll draw another one here, going north to south, and we can draw a few more. Don't go too crazy, they shouldn't be touching. And then you can show that they go all the way around, and they come all the way back in, and they go all the way around, and they come all the way back in, and then always show that this ultimate last one is going out and into the south. Great. So then we can move on to 9.6, and I'm going to erase some of this stuff here to make some space. Okay, so 9.6 says bars A and B are now removed and the points of attachment are now 2 centimeters as shown in the diagram below. So they've moved X and Y closer together. So 9.6.1 says how will the change in position of the attachment affect the final distance of separation between the bars? Okay, so we know that it's going to be less than 5 centimeters. So let's just write it down here so we know 9.6.1 less than 5 centimeters. And why is that? So 9.6.2 asks us to explain that. So we can just think about this. So first of all, we don't have a B magnet or that iron bar that is attracting the Y bar magnet further away from it. So now we don't have another opposing force pulling it the other way. So that could be a result. That could cause the distance to be not as far away. And secondly, that gives the X magnet an overall larger effect on Y because of B not being there anymore. And the distance is smaller. And we know that force, well, magnetic force, is inversely proportional to the distance between the magnets. So the closer the magnets are to each other, the stronger the force is. So you know that we do inversely proportional by doing the same proportional sign. And then I'm just going to say 1 over the distance. This means inversely proportional. So that could be the reason why it's less than. So because they are now closer together, there's more of a force pulling them together, which means they're going to, well, pulling them apart, which means that there's less than 5 centimeters between them. And additionally, there's no B bar magnet drawing the Y bar magnet further away, which is why the distance is less than. Okay, well, I hope that makes sense. But before I go, I'd like to say a very special thank you to our epic sponsor for making this video possible. You can read all about them in the description below. You can be sure to visit our website for more of these epic tutorial videos. And if you can't find the answer to your question, you can send us the question and we'll respond with a personalized video just for you. But until next time, stay epic.